right, so currently two of the more popular methods for building out an LLM solution are fine-tuning the model and or using the RAG methodology. Since the AI landscape is constantly changing, these methods will change over time. But for now, fine-tuning involves taking the LLM and further training it on a specific dataset or task. This makes it more accurate and effective in tasks related to that fine-tuned domain. You should do this if you want the model to adapt to and excel within a specific domain. Examples would be things like text generation for a specific industry, or perhaps sentiment analysis on domain-specific texts. RAG is what we'll be using, and it's also the diagram that you're currently looking at. So this stands for Retrieval Augmented Generation, and it enables contextual retrieval, which is what we want the chatbot to do: retrieve the relevant context from our private dataset. Basically, what we do is we create an index of our private dataset. For this project, you can imagine that our dataset contains various documents like PDFs, .text files, spreadsheets, and .doc files. The index that we create contains the document's text and corresponding text embeddings generated by an embeddings model in the form of a vector. This is what's stored in that vector store right here. So again, it's an index of your documents containing the document's text and corresponding text embeddings in a form of a vector. When a user asks an LLM a question, the text embeddings model converts their question into an embeddings vector. This vector is then compared to the vector store via a similarity search. And similar vectors containing the relevant text chunks from our private dataset are then provided within the prompt to the LLM, alongside the user question, of course. This user question and the new augmented prompt containing the relevant text chunks allows the LLM to generate an accurate answer using the correct context. Because the LLM is producing answers that are contextually informed by the retrieved knowledge from our vector store, the answers are more accurate and relevant. So while fine-tuning an LLM involves retraining the LLM, RAG simply retrieves information from our private dataset within this vector store, that's the R, augments the prompt by adding the retrieved context chunks to it, that's the A, and then generates an answer based on the augmented prompt, that's the G. Because it's pulling directly from our knowledge base, the likelihood that the LLM hallucinates, where it generates incorrect or unrealistic answers, greatly decreases. It can still happen, but it'll be much less likely. Because in fact, when we use the RAG methodology, we can even see the exact documents within our private dataset that the LLM used to generate its answers. So we can be certain it's using our knowledge base, and we can even go back to the specific documents and fact check its answers, rather than it going rogue and crafting its own responses.